right, so the very first section that we will come on the test will be geometric mean. And you, for the first beginning questions, you're just taking and multiplying 8 times 12. So the geometric mean is the square root of the two numbers that we're finding the geometric mean between multiplied. So we do square root of 8 times 12. And you can plug that into your calculator and you get 9.8. And we'll just go out one decimal place if it doesn't say. Same thing here, square root of 3 times 15, or square root of 45, if you want to look at that. And then again, plug that in your calculator and give me the decimal, so 6.7. So that'll be your beginning question. And then your progressing question will come straight from what we know the geometric mean is. So remember, the altitude here is the geometric mean between the two straight from it, two sides that are broken into parts. So x will equal the geometric mean of 8 times 23. And again, just plug. Once you know which ones it is, it should be pretty easy to plug in. So 13.6. And then y is the geometric mean, so the legs are the geometric mean between the side that it is straight from it, and the side around here, so this total side, which is 8 plus 23, which is 31. So y is the geometric mean between 8 and 31. So 15.7. And then z is the geometric mean between 23 and 31, because it is also a leg. So this first section will be just finding the geometric mean. The sides that you're looking for, the parts you're looking for, are all going to be straight from the straight finding a geometric mean between the two numbers. So you just have to know which two numbers you're finding the geometric mean of, so 26.7. And so those are my 3 sides. So x would be, so I can figure out this side here is 19, x would be the geometric mean between 19 and 6. Which is 10.7. And check it along with the video so that you again make sure you know how to plug it into your calculator. Y is the geometric mean between 6 and this whole length, 25. Just 12.2. And z is the geometric mean between 19, because that's the side opposite, and the whole length. So 21.8. So then when we get into proficient, if we truly understand how we found x, we should be able to work backwards. And so 3 was the geometric mean between 2 and x. So they took the square root of 2 and whatever x is, and they got 3. So 3 equals the square root of 2 times x. And then I can square both sides. So 9 equals 2x, and then divide by 2. So squaring this gets rid of that radical, 4.5. So x equals 4.5. And then once I have x, z is pretty easy because it's just 2 plus 4.5. So that is 6.5. And then y is the geometric mean between 2 and this whole length, which is 6.5. So 2 times 6.5. 3.6. So, and then here again, same thing. You're going to have one that was the geometric mean. So 10 is the geometric mean of the side from it, straight from it, and around. So y 10, they got 10 by taking, 10 equals the square root of y times 20. So they took y, whatever y is, times 20, and they got 10. So if I square both sides, I get 100 equals 20y, and then divide by 20. So y equals 5. And then once I have y, x is pretty easy because I just subtract that from the 5 from the 20, so x equals 15. And then z is the geometric mean between x, which was 15, and 20. So 15 times 20. Or 17.3. Right. And then the advanced here, an airport, a factory, and shopping center are at the vertices of a right triangle formed by 3 highways. The airport and factory are 6 miles apart, so since that's my biggest amount, I know the airport and factory have to be my hypotenuse. So that is 6. And then their distances from the shopping center, so that has to be shopping center, are 3.6 and 4.8. And it doesn't really matter how you draw that, but we want to make this service road right here. So first I'm trying to find this, like this is my end goal, but I'm going to use one of these sides to figure out like what this part is. So we know that they got 4.8, we'll call this part A, and this part B, because that's what x is the geometric mean between those two parts, and they're not split evenly. So 4.8 they got by taking the square root of 6 times A. And so we can square both sides. .8 squared is 2304, and then divide both sides by 6. So A there, this part is 3.8. Or 3.84, which makes this part 2.2. So then x is the geometric mean between these two parts. And I found that 2.2 by taking 6 minus 3.8. So x equals the geometric mean between 2.2 and 3.8. So I get 2.9 or 2.8. And then we went into the Pythagorean Theorem. So that's this one. Remember, Pythagorean Theorem is leg squared plus leg squared equals hypotenuse squared. So 8 is a leg, x is a leg, and 17 is a hypotenuse. And this is a triple, so you could also, like if you knew your triples, I'm not going to give those to you, but you could see that this is 15, right, because we have that triple 8, 15, and 17. Or if you don't want to memorize your triples, you could do 8 squared plus x squared equals 17 squared. So 64 plus x squared equals 289. And then subtract 64. X squared equals 225. Square root both sides. X equals 15. So you don't have to use the triple. They're just saying that there so that you could see that that's what that is. So same thing here. This is 9 times 5. And this is 4 times 6, so that won't work. We're trying to get them to be multiples of the same thing. So 3 times 15, and this is 3 times 8. So then this would have to be 3 times 17 if you use the triples. Again, you could do it the way I did the other one, where you could take 45 squared plus 24 squared, and you would get the same thing. You should get 51. So you could try that. So then here is just this using the Pythagorean Theorem. These are not triples. So 3 squared plus 3 squared equals x squared. 9 plus 9 equals x squared. Wanted to put my 18. And then 18 equals x squared, and then once I'm down to the numbers, notice here I square first before I add, so you want to make sure you do that, and I get x equals 4.2. Not the square root of 4.2, that would be a wrong answer. All right, and then here we would do 25 squared plus x squared equals 65 squared. 625 plus x squared equals, let's calculator, 4,225, and then subtract 625. So x squared equals 3,600. So x equals, if I square root both sides, 60. All right, and then here we were classifying whether this is acute, obtuse, or right. So when I take this, we're checking to see how does 30 squared plus 40 squared, how does that relate to 50 squared? And again, we want to also check to make sure 30 plus 40 is greater than 50, which it is. That makes it a triangle. So 900 plus 1,600, that is equal to 2,500. So those are equal, so this would be right. All right, here we do 20 squared plus, it might be easier to see it this way, I think, 40 squared. How does that relate, again, to the two smaller squared and added? So 20 squared plus 30 squared, so 1,600. How does that relate to 400 plus 900? 1,600 is greater than 1,500. Or 1,300, sorry, when I add that together. So that would make this obtuse. So if the two sums are greater than, it's obtuse. If they're less than, the two sums squared are less than, then it's right. And then you would do the same thing there. I'm not going to go through that for time's sake so that we can make sure we have enough time. Construction workers are building a marble sidewalk around a park that is shaped like a right triangle. Each marble slab adds 2 feet to the length of the sidewalk. The workers find that exactly 1,071 and 1,840 slabs are required to make the sidewalk along the short sides of the park. How many slabs are required to make the sidewalk along the long side? So here you would just do 1,071 squared plus 1,840 squared, and that will equal the long side squared, or the hypotenuse squared. And I'm going to let you work that out again for time's sake. I think it's 2,129. So on this part, we were looking for, sorry, it's kind of moving fast so that we can not run out of time. We're looking for the trig ratio. So all I want is the fractions. So sine j, remember, we've got so, ka, toa. So sine j would be opposite of j over hypotenuse. Opposite of j is 12 over hypotenuse, which is 20. And then for the decimal, I just take 12 divided by 20 and get 0.6. And then cosine L, oops, that's a C. Cosine L is adjacent over hypotenuse, but we're at L, so adjacent to L would be 12 over 20, which equals 0.6 again. So that's what we're looking on that, not for the angle, not for the decimal of the angle, just that. Right, and then here we're going to use our trig functions. So I'm going to just do this progressing, and then I think that we will be out of time. So we have to figure out how x relates to 36. It is opposite, and 7 is adjacent. So we're going to use tangent. Tangent 36 equals opposite x over 36. So the variables up high, we're going to be multiplying. This is x over 7. So we're multiplying both sides by 7. And then I'm going to plug that x equals 7 tangent 36 into my calculator, and you should get 5.1. All right, we will